Now, cosine is also considered a sinusoidal graph because like if we just did this part of the sine and kept going, that would look just like a cosine. So you can write sine using cosine equation and cosine using sine. It just has some shifting. All right, so like I said in the previous lesson, we identified the midline, amplitude, and period of sinusoidal functions. And now we're going to look at more like what they're going to do. And like I said, we're going to be able to write equations of sine and cosine functions. So the midline is always just the vertical translation. So once you figure out what the midline is, that part is going to be added or subtracted at the end of the function, like a vertical translation. The amplitude is going to be a vertical dilation, so either a vertical stretch or a vertical compression, and that has to do with what is in front of the sine and cosine. And then the period is a horizontal dilation, so a horizontal stretch or compression, and so that is going to be multiplied inside of the function by the theta or by the x or t or whatever is going on. Okay. And so just to be a little more specific, we're going to have A represents the vertical dilation, D represents the vertical translation, and then the horizontal dilation is going to be 1 over B, or the reciprocal of B. Now, one thing that is on here that I disagree with slightly is that it says A represents the amplitude of the graph. Well, sometimes A is negative. So let's just squeeze in there that the absolute value of A represents the amplitude of the graph. The amplitude can't be negative. So if A is negative, you just say it's positive. What do you think that negative A means? Like if there was a negative in front of your sine or your cosine, what transformation is that? Good. That's going to be reflection over the x-axis. And that comes up, and we'll do some of those today. Right. And another thing that we need to pay attention to is this right here. That if we're wanting to find the period of a sine or cosine function, we take 2 pi and we divide it by whatever number is being multiplied by x or being multiplied by theta. That will always give you the period if you have the function. And we're going to use that in reverse. So we're going to have the period, and we're going to need to find what b is. Okay, let's just do some examples. That's a whole bunch of words. All right, so on example 1, we have the graph of h. It's sinusoidal, obviously, and we are going to find what a, b, and d are in the equation of this function. So let's just start. I think it's easiest to start with d. We can start wherever you wanted to, but d is always equal to whatever the midline is. So what is the midline of this one? 3. So it's just going to be d equals 3. All right. A is probably going to be the amplitude unless there was some type of reflection, and there wasn't in this problem. So in this case, A is going to be 6. All right. And then this shape right here is 1 cycle of the sine function. And so how long did it take to complete 1 cycle? Or what is the period? Pi. All right, now we're going to use that period to find b. So up here on number 3, we said the period is equal to 2 pi over b. So I'm going to take our period, and we're going to set it equal to 2 pi over b. Now, in geometry, I think that maybe your geometry teacher taught you, if you have a situation like this is the variable we're looking for, that you can just switch these. Do you guys remember doing that? So we can just put the b where the pi is and put the pi where the b is. Now, if you don't like that, you can just solve the equation. All right, so if we have a variable on the bottom that we don't want on the bottom, we would multiply by that. And then to solve, you would divide by pi. So it works out the same way every time, I promise. But if you notice, if it's a situation like this, you can just switch those two things and you'll be done. Well, almost done. What is 2 pi divided by pi? 2. E is 2. So we have A, B, and D. All right. We're going to do some more, so don't worry. All right, so on example 2, we're going to do all those things we just did plus a little bit more. So this one doesn't tell you to write a sine function or to write a cosine function. The last one told you to look at sine. But if I go to the beginning of this graph and I draw, does that look like a sine or a cosine? That looks like a sine. So we're going to write a sine function. All right, what is D? 3. That's the midline. What is A? Also 3. So A is going to be the distance between the midline and the max. Okay, so now what we have to do is figure out B. All right, so how long does it take this to complete one cycle of sine pi? So apparently pi is a favorite period because, again, we're going to get that B is 2. So we're not quite finished. So our final answer, we're going to take A, B, and D and plug them into that function. Oh, don't use X, sorry, use theta. Okay, so that's the equation of that sine curve. All right, you guys okay? Okay, so look at the next one. All right, so this one is a little different. If I go to draw it from 0, that is 1 period, but that's an upside down sign. So this one, like if we wrote the equation for G, it's definitely going to be negative something sine of something. It's not asking us to do that, but I just want you to recognize that whenever it's an upside down sign, that very first part is going to be negative. We don't need that to do this problem though. All we need is the period and the amplitude. So what is the period? Pi. So we can eliminate C and D because it completes a cycle. Even though it's an upside down cycle, it's still a cycle. All right, and then the amplitude is the distance from the midline to the max. So what do y'all think? 2. So the midline to the max is 2 units. All right, let's look at 4. So 4 starts off similar to some problems that you guys had on your last assignment, but we're going to do more with it. And so it tells you that the trigonometric function k has a maximum at 0, 6, and then the next minimum is at pi over 2, negative 4. So we can use that information to get the period. Now, I want to draw your attention to something. So typically, if there's no, not shifting or stretching or stuff, the maximum of sine occurs at pi over 2. Where does the maximum of cosine occur? What x value or theta value? A 0. So when you see this, and it doesn't really matter for this question, but when you see that either the maximum or the minimum is at 0 something, more than likely that's going to be a cosine function. We're going to say the parent cosine function has a max at t equals 0 or x equals 0, whatever you want to say. So I just say that because when I worked through your homework, like some of these would be cosine and some of them would be sine. So you need to be able to recognize that. All right, so the whole point of them giving you a maximum and then the next minimum is so you can figure out the period. So half of a period is going to occur between a max and a minimum. So what is half of a period for this one? Pi over 2. So the whole period is pi. Nice job. So we can use that to figure out b, but we have done like 4 problems now where the period is pi. So what is b when the period is pi? 2. It's been that every single time. So it's going to be one of those two, either b or d. So to make the decision about that, we have to know the amplitude. So we know that the midline is definitely 1. Like we could find it numerically if we wanted to. I'll write down how to do that in case you need to. So the midline, you're going to add the max and min y's and divide by 2, which is going to give you 1. We didn't need that because we already knew it was 1. Now what do we do to find the amplitude? Yeah, so take a max, subtract the midline from it, and that's it. So it looks like the answer is going to be D. All right. So on example 5, we have a function f that's f of x is 3 sine of 2x minus 1. We want to figure out which one matches that graph. So first thing I usually notice is the vertical shift or the midline. So where should the midline be? Should be at -1, right? So which one can we eliminate? A. So it's definitely not A. So we don't even need to look at A. Okay, so let's look at the period. So when you have the equation of sine or cosine, the period is found by doing 2 pi and dividing it by the coefficient of your variable. So this one should have a period of pi again. So which one of those that are left as answer choices has a period of pi? C. So this is one cycle. Now I didn't really worry about the amplitude because all of our choices had an amplitude of 3. All right, you guys all right? Okay, so the hardest thing to picture and imagine is the phase shifts or the horizontal shifts. And so that's why I'm going to hand out these pipe cleaners, and you guys can use them or not. It's up to you. So a horizontal shift in a sinusoidal function is called a phase shift, but it's the exact same thing. And so if we have sine of x plus c, then the phase shift is going to be it's going to come from that C. It's going to be the opposite. Just like it always is on the inside, it's going to be the opposite or the reciprocal. And then same thing for the cosine function. Okay, so we have this trig function that is G. I'm going to hand out some of these guys. So just take one, pass it back. Doesn't matter what color. Unless you're picky. All right, so if you guys just were going to guess, because looking at this, you would just have to take a guess of if you think this answer is going to be sine or cosine, which do you think it's going to be? Just guess. Someone thinks it's going to be sine? Okay, so what we're going to do is take our little pipe cleaner and start at a middle, go to a max, and then back to a middle. Just following along the curve of it, like actually use what's on your paper. Middle, max, min, and back to the middle. Now it's not going to be perfect. Just try to get the basic shape. All right. So when you're done, you should have a little guy that looks kind of like this, or maybe like that for you. All right. So our choices for sine were these two. And so what we're going to do is take this little guy that's just like the 3 sine of x and put it at 0. So space it like this on your paper. All right, and so then the pi plus pi over 2, which way is that going to shift it? To the left or to the right? To the left. We don't really have that on our graph, but you can estimate. So this is pi over 2 distance. So we're going to take that much and shift it to the left. So take your little guy from 0, shift to the left that much, and then down 1. Does that lay on top of the graph exactly? It shouldn't. It should look something like this. So C is not an answer. That's okay. It might be D or it might be a cosine graph. So let's see what happens. So we'll take it again, put it at 0. So you're laying it, I know this is hard to see, you're laying it like this. All right, what is that negative going to do? The negative in the front, what is it going to do? It's going to flip it upside down, right? So take it and flip it. And then minus 3 pi over 2 on the inside, which direction is that going to shift? Left or right? Right. So shift right, 3 pi over 2, and then down 1. Is it on top of it? It should be. That's the answer. All right. We're going to do another one. Okay, I don't remember what this answer is, and I'm not looking at my answer key, but I want to at least do some of the shifting with the cosine graph. It might be a cosine, it might not. I don't really remember. So take your little pipe cleaner. A cosine is going to go from a maximum all the way to another maximum. So try to make that shape. I got a little extra. You should look a little bit like this guy. I got a little extra on my end though. All right, and then what you're going to do is take the maximum and have it be on the y-axis, preferably at 2. So as you look down here, all of these have an amplitude of 2, which means that that's going to be your maximum will be at 2, your minimum will be at -2. So lay it right there. And we're checking the cosine graphs because we have a little cosine curve. So the first cosine graph shifts it pi over 4 to the right. So halfway between pi over 2 and 0 to the right, and then up 1. Is that the right graph? Okay, so this is where you're starting, like this. If I take that and I shift it pi over 4, so pi over 4 is between 0 and pi over 2. It goes to here. And then if I shift that up 1, is it going to be in the right place? Absolutely not. So that is not an answer. Okay, so we're going to take it again. We're going to start back at this. We're going to start back at this graph right here. So B tells us to take that and shift it pi to the right. So if I take it and I shift where that maximum is at 0, that maximum is going to go to pi. And then up 1, is that going to be right? I don't think so. So when we shift it, pi goes to here. Okay, so just kidding. It's not sine. It's not cosine. It's going to be sine. All right, so this is what I'm doing. And if you don't want to do the pipe cleaner, you can do it in your head, or you can just redraw a bunch of them if you want to. If you want to do the pipe cleaner, you make this shape right here, a sine curve that matches the heights of this curve. I'm going to go to the other side. All right, so it looks kind of like this for y'all. So we always want to start at 0. So on the sine curve, this endpoint is at 0, 0. So C wants us to shift that pi over 4 to the right and then up 1. Does that lay it on top of the graph? Yeah. So until you really get used to what these look like, I think it's these shifts and reflections I think are kind of difficult to do. Okay, and then the very last example, we're going back to this guy that we worked with a lot. So when we first started doing this, we had to figure out these ordered pairs by using the context of the problem. So there's another question that will be on that FRQ that after you figure out those, you're going to write the equation of the graph. But on this, some of the difficult part is already done. So what you can do just by looking at those ordered pairs is know that F is at 216. So that means this is 16. That height is. I know G is at 511 and J is at 86. Just kidding. Okay. And then what we're going to do is figure out A, B. Now we have to figure out C and D just from looking at those points. So to me, D is always the easiest to figure out. What do you guys think D is by looking at what we just wrote? 11. It's just going to be the middle height. A is going to be the distance between the middle and the max. What do y'all think? 5. Good. All right, and then we've done several problems where we've found B. But you need to pay attention to your points. Bless you. What is the period of this graph? What's the distance between this max to this max? Yes, thank you. All right, so we're going to take 12 and we're going to set it equal to 2 pi over b. So what's b? Yep. So just like the ones we were doing, we're going to switch 12 and b and then simplify it down. It's possible that on the AP test, you might not even have to simplify that. I'll have to look up what it says. Okay, and so now we have to find C. And there's lots of different ways you can approach C. C is going to be the shifting that has occurred. There is a methodical way that you can do it that you will get the right answer on C every time. So I'm going to show you that. If you can figure out a logical way to figure out C, that's fine. These problems are just so different so many times. Like sometimes these are at fractional values and sometimes they're at decimal values. But one thing that we talked about at the very, very beginning is that sine, the parent function of sine, has a maximum that occurs at pi over 2. So let's just reiterate that. So what we can do is take the part of this function that affects the horizontal dilation and horizontal shifting, which is this part right here, and set that equal to pi over 2. And that's going to be where your new max occurs. I kind of worded that weird. So what we're going to do is take that b times t plus c and set it equal to pi over 2. And then we're going to be able to fill in values and solve it for c. So what did we say b was? Pi over 6. So we can just replace that. And then the t that we're going to use needs to be a t located at a maximum. We have two options. I always just pick the first one. I always just pick the value at f, but you could definitely do p. There's more than one answer here for sure. So t is going to be 2. And then that's going to be the x coordinate of f. All right, and then that's going to equal pi over 2. That technically is the t coordinate of f. Okay, so we're going to solve this for c. We are not going to distribute pi over 6. We could. It 100% would work. But it's going to make it easier if we get rid of that pi over 6 a different way. What could we do? You're going to multiply by the reciprocal of it. All right, so that's going to give us 2 plus c equals, and then those pi's cancel out, and then 6 divided by 2 is just going to be 3. And so c is 1. We have our a, b, and c. All right, any questions? That's a methodical way to get the answer. A logical way to get the answer is draw the x-axis and then figure out where that is. Then that's up to you. I'm pretty sure someone in my last class figured that out before I taught it. That's fine. But what we just did will give you C every time. Now I was working. There's 3 worksheets that go along with this lesson, and I was working through them. And I got to the last one and I missed that question on the last 2 problems. And I'm like, what is happening? And I realized that they just threw in that this was cosine instead of sine, which totally changes where the maximum would occur. So just pay attention. It's not going to happen on today's assignment, but tomorrow, if that is cosine, you don't set it equal to pi over 2. What do you think you would set it equal to for sine? Where does the sine max occur? A 0. You'd set it equal to 0. So anyway, I'll remind you of that tomorrow. Don't worry.